Good evening, everyone, and welcome to the plenary room of the Portage County Public Library for tonight's installment of the University of Wisconsin Students 20 College Honors and Science Community Lecture Series. My name is Todd Good, and I'm the Interim Associate Dean in the college. And tonight's lecture is presented by David Snyder, an assistant professor in the Department of Chemistry. Professor Snyder's topic tonight is Acid Rain to Wood Smoke, Air Quality Challenges in Wisconsin. Dave earned his bachelor's degree in chemistry education from Ferris State University in Michigan and his PhD in environmental chemistry from the University of Wisconsin-Madison, where he developed methods for studying air pollution using real-time instruments. His research has allowed him to study air quality in numerous air pollution hotspots, including Los Angeles, Mexico City, St. Louis, Cleveland, and Detroit. Most recently, Dave and his research students at UWSP completed a study of the impact of residential wood smoke on local scale air quality in Grand Rapids, Wisconsin. Wisconsin.
The easy mistake to make.
It is. I just made it. The study, funded by the Lake Michigan Air Directors Consortium through a grant from the U.S. Environmental Protection Agency, was the first of its kind in the Midwestern United States. Despite being a native of Kalamazoo, Michigan, Dave is actually a lifelong Packers fan and would consider giving up his loyalty to the Red Wings if someone from Wisconsin, such as the Bradley or Pettit families, would purchase a NHL hockey team. If you could cheer for the Wild, that's actually acceptable.
Well,
Dave, his wife Ann, and their son Reese, an 8th grader at PJ Jacobs, moved to Stevens Point 3 years ago from Madison, and in his spare time, Dave enjoys making sawdust, noise, and other useful items in his basement wood shop. Just a note on the format tonight. Dr. Snyder will speak for approximately 45 minutes and will answer any questions that you may have afterward. And although the library usually closes at 8 p.m., they've allowed us to stay a bit later if necessary. So with no further ado, I'd like to introduce Professor David Snyder.
thanks. Well, good evening, and thank you for coming. I appreciate a captive audience, at least an audience that's interested. At home, I tend to wax a little lyrical about things scientific. My wife is very patient, but after a while, I think her eyes kind of glaze over and she says something, science, 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 blah, blah, blah. I have 113 students that I'm teaching this semester. They're definitely a captive audience, and sometimes they, are interested in what I have to say, and sometimes, well, science, 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 blah, blah, blah. So it's always a pleasure to speak to an audience of folks who are very interested in the topic that I have to present. I hope that you find some useful information tonight in the talk, which is about air quality in Wisconsin. And before I sort of get started, just so that I know a little bit more about the audience here, I'm just going to ask you, whether you've heard of some of these air pollutants. And if you have, just raise your hand so I get some sense of whether you've heard of these things or not. So how many of you heard of ozone before? All right, okay. How about carbon monoxide? How about lead? How about nitrogen oxides? All right. Sulfur oxides? All right, we're doing pretty good. How about particulate matter? Oh, great. Well, let me tell you that as a whole, you know more about air pollution than I did when I started graduate school. I knew absolutely nothing about air pollution. I'm not even sure that I knew that ozone was necessarily a bad thing when I started graduate school. And I started at the 1st of June. By the 1st of July, I was headed to Los Angeles, California, with about $500,000 of equipment in the back of a minivan that I kind of knew how to operate. And I got a real crash course in air pollution. So this should be a nice, easy talk because you guys know some of the vocabulary already. So the first question is, what is air pollution? It's actually a topic of some discussion lately, the last couple of years. What exactly constitutes air pollution? The thing that most people are having debates about right now is carbon dioxide. Is carbon dioxide air pollution or is it not air pollution? The World Health Organization defines air pollution essentially as some substances that are released in the air by the activity of mankind in concentrations high enough to cause harmful health effects that affect property, crop yields, and the enjoyment of property. What you might not know is that in 1970, the Clean Air Act was passed, And the verbiage of the Clean Air Act is really quite vague about what is air pollution. It's really quite open. It essentially says anything released in the air can be considered air pollution. But the EPA has actually had a very narrow interpretation of what constitutes air pollution. So here are sort of the lists of the big ones, the big six. These are called the criteria air pollutants. So they're ozone, particulate matter, nitrogen oxides, carbon monoxide, sulfur dioxide, and lead. So the EPA maintains the national ambient air quality standards to help protect human health and human welfare based on these 6 pollutants. And the pollutants themselves are kind of related to one another. They don't just sit in the atmosphere all by themselves. And we'll see sort of that interplay this evening as we talk about these particular pollutants. In addition to the criteria air pollutants and the National Ambient Air Quality Standards, they actually have sort of a forecasting and air quality index called the AQI. And it's color-coded from good up to hazardous. Has anybody seen an AQI forecast before? Okay, a few of you have. Well, on the sheet that I handed out today, you'll notice there are a couple of links that you can go to, and you can get sort of real-time look at the air quality in Wisconsin as given by the Air Quality Index. So good is air that poses little or no risk to anyone. Moderate, there might be a few people who might have some problems with air quality on a moderate day. And today was actually a moderate air quality day. Has anybody feel any effects today? No, probably not. But you did feel some effects of it today? Okay, all right. So folks who... Okay. So I was sitting in my office, and I happened to have an air monitor with me in the office that I wanted to bring today, and I turned it on, and I noticed that the air quality in my office wasn't so good. So I thought, where did that come from? And I stepped outside, and sure enough, the air quality was not so good outside. And when I went to look at the DNR's forecast, it certainly was a moderate day. So we work up from moderate to a level of concentrations that are unhealthy for sensitive groups. Okay, so folks who are predisposed to having issues with cardiovascular problems, with asthma or allergies. And then we get up to unhealthy levels in which everyone should sort of feel some sort of effect. And so this scale is one that I'm going to use later on in the talk tonight to describe some of the air quality that we measured in Grand Rapids, Wisconsin during our wood smoke study. In addition to the criteria pollutants, there are also hazardous air pollutants. Now these are pollutants that are released sort of in smaller amounts, but are known to be carcinogenic or cause other health effects, reproductive effects, and adverse environmental effects. And right now there are 187 of those on the list. And these are traditionally controlled at the source. So the EPA, the DNR, they require that sources of pollution actually have what's called the MACT, the maximum allowable control technology, or maximum available control technology, to make sure that they're not emitting too much of these chemicals. And the classic example of a HAP or hazardous air pollutant would be mercury. That's the one that most people are familiar with. Mercury is rather difficult. Some of these are rather difficult to actually measure in the ambient air because they're there in small amounts, but they tend to accumulate in soils and in waters. So as far as where pollution comes from, we can sort of break it up into a couple different categories, and one is anthropogenic sources of pollution. So pollutants that result from human activity. So the World Health Organization has basically said that these are the pollutants that we're concerned with, but we can also talk about biogenic pollution sources, and we'll see how that sort of comes into play later on. So there are volatile organic compounds that come from natural sources. So if you have ever walked into a pine forest and you've smelled that nice pine smell, those are actually organic compounds that come from the plants in the forest, from the pine trees, and those actually can cause us a little bit of trouble in areas where there might be some other pollutants present. Ammonia is actually a big one here in Wisconsin. It's also a big one in Los Angeles. Do you know where ammonia comes from? What the natural source of ammonia is? Cows, okay. So when you mix the urine and the feces from the cow, you've got a nice ammonia production. And so that ammonia also can be a little bit problematic when it comes to air quality. We can talk about pollutants that are primary pollutants. So these are things that are emitted directly to the atmosphere. And we can also talk about secondary pollutants. And these are things that are actually formed through chemical reactions in the atmosphere. And an awful lot of the things that we're concerned with in Wisconsin are things that are secondary pollutants and not necessarily primary pollutants. So where do these things come from? And this is one of the things that I really got interested in when I was in graduate school, is the trouble with combustion. So I think most folks kind of assume that air pollution comes from combustion processes, that it comes from the fuel itself, that it's the fuel that we burn that creates these air pollutants. And that's not necessarily the case. So if we look at the general chemical reaction that governs sort of a combustion process, we have a hydrocarbon fuel, let's say the gasoline in our tank. We react it with oxygen, and classically we get water and carbon dioxide. Now, unfortunately, that's not all that we get. One of the problems is that combustion takes place at high temperatures. And normally in the atmosphere, we have a lot of nitrogen floating around, we've got oxygen floating around, and the nitrogen in the atmosphere, thankfully, is not very reactive, which is a good thing because it composes 78% or so of our atmosphere. But at high temperature, that nitrogen becomes reactive, and it does react with oxygen to produce things called nitrogen oxides. And this is one of the ways that nitrogen oxides are formed, is through the actual heat of combustion. We get reactions between nitrogen in the air and oxygen in the air. And these are things that are not coming from the fuel, they're already in the air, and it's just the heat of combustion that's creating those. One of the interesting sources of nitrogen oxides is lightning. So when you get a lightning strike, the air around that lightning bolt is superheated, and it helps to make that nitrogen reactive, and it'll react with the oxygen, and it's actually a significant source of nitrogen oxide. So here's a natural source, if you will, of some air pollution, some nitrogen oxides. Now, of course, the fuels do contain things that potentially are problems as far as air pollution. There's sulfur. So when we burn sulfur-rich fuels, we get sulfur dioxide. There are metals in fuels. Coal notoriously has mercury and other heavy metals in it. And there's nitrogen in the fuel as well. And so that nitrogen in the fuel can also become nitrogen oxides. So it was very interesting to me when I was learning about this that some of these pollutants actually come from just the fact that we're burning something in the presence of air, and that the air itself, being so warm, actually becomes reactive and gives us these nitrogen oxides. And we'll talk about these nitrogen oxides tonight because it turns out that they are sort of one of the big problems that we have in Wisconsin and other places. What those nitrogen oxides do when they get in the atmosphere and what they become is of some concern. So you might say, well, I drive a car and I know my car has a catalytic converter and it does a good job of controlling the air pollution that comes out of the car. And while this is true, and while the invention of the catalytic converter has done a lot for air quality, the problem is this. When California was the big state that pushed forward with air quality regulations, and when they introduced the catalytic converter in Southern California, they noticed something really interesting. And that is, even though they had all of these catalytic converters out there, they still had a lot of air pollution. And what they discovered was that 90% of the air pollution was caused by about 10% of the cars. And we call these things smoking vehicles. Sometimes they're called pounders because they emit a pound of pollution per mile as they go down the road. So we're talking about cars whose catalytic converters don't work very well, cars that burn a lot of lubricating oil. So these smoking vehicles, any sort of poor combustion that goes on can create pollutants as well. Carbon monoxide for one. We can get partially or unburned fuels or motor oils from these vehicles as well. So we not only have a problem with combustion, but we also have a problem with the atmosphere. So the atmosphere is kind of sometimes not really our friend here. The first problem is that when we emit things into the atmosphere, they just don't float around as is. They tend to react with one another, and they can even produce more pollution. And the reason is that we have sunlight. And so sunlight contains a lot of energy, and that energy can actually charge up those molecules and make the reactions possible. And we also have water in the atmosphere. So a lot of the reactions that take place to produce pollutants in the atmosphere take place in clouds and fog water. And this is one of the reasons why people are talking more and more about CO2 as a pollutant, at least in my field. Because with more CO2 in the atmosphere, with the climate getting warmer, we're also getting more water vapor in the air, and we're getting more heat in the air, and these things actually help to push some of these chemical reactions in the atmosphere that produce pollution forward. The other problem that we have in Wisconsin is that it gets cold here. It gets very, very cold. And what happens when air gets cold and dense? It falls down. Okay? In the wintertime, all that cold, dense air falls down towards the ground. Okay? And it creates what's called an inversion. So all the cold air is really dense and it sinks. And above it, there's actually a pocket of warmer air because all the cold air has sunk down. And now when you emit pollution into that cold air, it's incapable of rising up. Okay? It's very cold down here. That air is cold. It tries to rise above into that warm layer air above, and it can't because it's heavier and more dense than the air above. And so you've probably, let me sneak through here, seen an inversion layer before. And this was sent to me by someone I met at a conference a couple of months ago. She lives up in Spring Valley. And so she's been looking at a couple of wood burners and looking to see what happens in the wintertime with these wood burners. And so there's one burner on the left-hand side and another one on the right-hand side. You can see that early in the morning at about 6 a.m., somebody throws some logs on the fire, and all of a sudden a plume of smoke starts to go up. But that smoke can't go up any higher. It's trapped now real close to the surface. And because all that pollution is trapped close to the surface, its concentration starts to build up and build up and build up. And so in the wintertime, this is a real problem in Wisconsin. This is why we have issues with particle pollution in the wintertime, because we have a lot of inversion conditions like this. We may not be burning any more fuel necessarily or driving our cars anymore, but this pollution tends to stay close to the ground, and because it stays close to the ground, the concentrations are higher. So most of you told me that you knew something about ozone. So there are two different types of ozone. There's ozone that's in the stratosphere, and that's good ozone. So that's the kind of stuff we like to see around. That's why we don't emit CFCs anymore to any great extent, because that ozone protects us from ultraviolet radiation. But we also have ozone in the troposphere, or the layer closest to the ground. And that ozone tends to be problematic for us because it's a lung irritant. Right? It can get into the lungs. It can trigger chest pain, coughing, congestion. Even repeated exposure to high levels of ozone can actually cause scarring in the lungs. So breathing ozone reduces lung function. It can cause inflammation. And anyone who knows or has had inflammation before knows that it can be difficult to breathe, it can be difficult to function, and it can exacerbate those pre-existing conditions such as asthma.